Hello students. I, Soumen sir, we going to solve some multiple type questions. Multiple choice questions with answers and explanations on basics of engineering materials. One question: what is the primary purpose of alloying elements in engineering materials? A. To increase hardness. B. To reduce ductility. C. To improve mechanical properties. D. To lower melting point. Answer: C. To improve mechanical properties. Explanation: alloying elements are added to engineering materials to enhance specific mechanical properties such as strength, hardness, toughness, and corrosion resistance. 2. Question: which type of bonding is primarily responsible for the properties of metals? A. Covalent bonding. B. Ionic bonding. C. Metallic bonding. D. Van der Waals bonding. Answer: C. Metallic bonding. Explanation: metals are characterized by metallic bonding, where positively charged metal ions are surrounded by a sea of delocalized electrons, giving metals their unique properties like conductivity and ductility. 3. Question: what is the process of transforming a solid metal into a liquid state by heating? A. Annealing. B. Casting. C. Forging. D. Extrusion. Answer: B. Casting. Explanation: casting involves melting a solid metal and pouring it into a mold cavity to obtain the desired shape upon solidification. 4. Question: which engineering material is primarily composed of carbon and iron, with varying amounts of other elements? A. Aluminum. B. Stainless steel. C. Copper. D. Titanium. Answer: B. Stainless steel. Explanation: stainless steel is an alloy of iron, carbon, and chromium primarily, with varying amounts of other elements like nickel, manganese, and molybdenum. 5. Question: what type of bonding is predominant in ceramics? A. Metallic bonding. B. Covalent bonding. C. Ionic bonding. D. Hydrogen bonding. Answer: C. Ionic bonding. Explanation: ceramics typically exhibit strong ionic bonding, where ions of opposite charges attract each other to form a stable crystal lattice structure. 6. Question: what is the primary reason for using polymers in engineering applications? A. High electrical conductivity. B. Resistance to corrosion. C. Low density and ease of processing. D. High hardness. Answer: C. Low density and ease of processing. Explanation: polymers have low density, making them lightweight, and they are easy to process into various shapes and forms, making them versatile for engineering applications. 7. Question: which material property describes a material's ability to withstand deformation under applied load without fracture? A. Toughness. B. Ductility. C. Strength. D. Hardness. Answer: C. Strength. Explanation: strength is the ability of a material to withstand applied forces without yielding or fracturing. 8. Question: what is the primary purpose of heat treatment in engineering materials? A. To increase hardness. B. To reduce strength. C. To enhance ductility. D. To lower melting point. Answer: A. To increase hardness. Explanation: heat treatment processes such as quenching and tempering are used to adjust the microstructure of materials to achieve desired properties such as hardness, toughness, and strength. 9. Question: which engineering material is known for its high strength-to-weight ratio and corrosion resistance? A. Aluminum. B. Brass. C. Lead. D. Zinc. Answer: A. Aluminum. Explanation: Aluminum alloys are widely used in engineering due to their excellent strength-to-weight ratio, corrosion resistance, and machinability. 10 question. What is the primary advantage of using composites in engineering applications? A. High electrical conductivity. B. Low density and high stiffness. C. Resistance to high temperatures. D. Transparency to visible light. Answer. B. Low density and high stiffness. Explanation. Composites combine two or more materials to achieve superior properties such as low weight, high stiffness, and tailored mechanical performance. 11 question. Which material property describes a material's ability to absorb energy and deform plastically before fracture? A. Toughness. B. Ductility. C. Elasticity. D. Brittleness. Answer. A. Toughness. Explanation. Toughness measures a material's ability to absorb energy and plastically deform before fracture, indicating its resistance to brittle fracture. 12 question. What is the process of compacting and bonding powdered materials together at high temperatures? A. Sinting. B. Extrusion. C. Casting. D. Forging. Answer. A. Sinting. Explanation. Sinting involves heating powdered materials to bond them together without melting, forming a solid mass with controlled porosity and improved mechanical properties. 13 question. Which material property is critical for applications requiring a material to return to its original shape after deformation? A. Toughness. B. Ductility. C. Elasticity. D. Plasticity. Answer. C. Elasticity. Explanation. Elasticity refers to a material's ability to deform under stress and return to its original shape when the stress is removed, important for springs and structural stability. 14 question. What is the primary advantage of using ceramics in high-temperature applications? A. Low melting point. B. High ductility. C. Corrosion resistance. D. High melting point and thermal stability. Answer. D. High melting point and thermal stability. Explanation. Ceramics exhibit high melting points and thermal stability, making them suitable for applications where metals would soften or melt. 15 question. What is the purpose of a material's Young's modulus, E? A. To measure electrical conductivity. B. To quantify hardness. C. To characterize stiffness. D. To assess thermal conductivity. Answer. C. To characterize stiffness. Explanation. Young's modulus, E, measures a material's stiffness or resistance to deformation under stress, indicating how much it will stretch or compress under a given load. 16 question. Which material property describes a material's ability to resist indentation or scratching? A. Toughness. B. Ductility. C. Hardness. D. Elasticity. Answer. C. Hardness. Explanation. Hardness measures a material's resistance to penetration, scratching, abrasion, or deformation. 17 question. What is the primary purpose of adding reinforcement fibers to composite materials? A. To increase electrical conductivity. B. To improve corrosion resistance. C. To enhance mechanical strength. D. To reduce density. Answer. C. To enhance mechanical strength. Explanation. Reinforcement fibers such as carbon or glass fibers are added to composites to enhance mechanical properties such as strength, stiffness, and impact resistance. 18 question. Which engineering material undergoes a phase change from liquid to solid without a crystalline structure? A. Metals. B. Polymers. C. Ceramics. D. Glasses. Answer. D. Glasses. Explanation: glasses are non-crystalline solids formed by rapid cooling of molten materials, lacking a regular crystalline structure like metals and ceramics. 19. Question: what is the primary reason for using stainless steel in applications requiring corrosion resistance? A. Low cost. B. High strength-to-weight ratio. C. Ease of machining. D. Resistance to oxidation and chemical attack. Answer: D. Resistance to oxidation and chemical attack. Explanation: stainless steel contains chromium and other alloying elements that provide superior resistance to oxidation, corrosion, and chemical attack in harsh environments. 20. Question: what is the primary advantage of using titanium alloys in aerospace applications? A. High electrical conductivity. B. Low melting point. C. High strength-to-weight ratio. D. Transparency to X-rays. Answer: C. High strength-to-weight ratio. Explanation: titanium alloys offer excellent strength-to-weight ratio, corrosion resistance, and high temperature performance, making them ideal for aerospace structures where weight savings are critical.